right. This is the Saturday Night Data Party Advanced Content Marketing Edition. So what we're doing tonight is a project that I've been meaning to get to for about 3 years now. Just never got around to it. And what we're doing is we're going to do some advanced content marketing. So one of the things about content marketing, it always puzzles me when I hear people say this, like, oh, we don't have any content. There's, back in my PR days, people say, oh, we don't have any news. Well, make some news. It's not that hard. You have to have a story, something worth talking about, and you need to create something that is interesting. So what we're going to do is we're going to take a nutrition database, a publicly available one, and convert it into some content marketing. So let's look at what this might look like. First, what is the database? If you've never heard of it before, Open Food Facts is a pretty cool free open project to the world. It's open source, and it contains 1.3 million food products of every kind, generics, brand names, prepackaged foods, you name it. And users take photos with their smartphone of like nutrition labels and upload it to this database. So this is a gold mine of stuff about all kinds of food from countries all over the world, 157 nations. You can get the actual data that makes the database itself. You can get it in a variety of formats. I've just downloaded the CSV format. The CSV format is actually a tab separated file. It's not comma separated. And I'm going to import this into R. Let's go ahead and get our libraries running here. Now, in the database, we have 1.1 million foods. First thing we're going to do, we need to do a bit of cleaning. The goal of this, by the way, is to come up with something that you can talk about. It's going to be a cool story. So let's do some cleaning. We're going to take that data frame, we're going to fix the names, because if you look at the fields, the names are kind of a mess. We're going to make sure we don't have any duplicates. We're going to make sure that different values are typed correctly, meaning it's like numbers, letters, etc. And then for anything that's a number, we're going to, that is not available, meaning it's blank, we're going to convert it to a 0. This is a huge database. 1.1 million lines of data, 2 gigabytes of text. Right? 2 gigabytes, just for comparison's sake, is about the size of like a 1080p movie. So if you download like a movie or you're watching something on Netflix, like a 90-minute, 2-hour movie, that's 2 gigabytes of data. So that's how much data is in this thing. We used to have a client back in my agency days. I mean, I guess Preston says still is technically an agency, but back in my PR days, we used to have a nutrition client. And this was one of those projects I always wanted to work on with them, but we could never get the funding or the approvals to actually do something like this. But wouldn't it be cool to take the idea of this database and build it into something that, custom, something that could make interactive? All right, so what do we got here? We should have a database that I'm still running, so it's going through still cleaning. Great. Same number. Yep, we lost 50 records because they were duplicates. Now, one of the things I want to do is in here, I want to restrict this. We're going to work with the United States, so let's take this and turn this into and countries. You just use country codes, but they don't have them. All right. Countries English. So here, we're now going to filter this table down to just foods available in the United States. Again, if this is your country, do what you like. Let's nuke just null it out. Yeah, let's null out. So I'm going to go ahead now and null out, remove data frame, remove cleanDF, because these are two very, very large objects that occupy a lot of memory. You don't have to do that if it's not something gigantic. So okay, we've got our clean USA data frame. Let's look at what's in this thing. Let's do 181 fields. Just going to go ahead and copy these to a text file. And let's make this a little more orderly. There we go. Okay, so here's everything that we've got. You'll notice there's a label called 100 grams. Basically, it's this ingredient and however much of it is in 100 grams of that ingredient. So we've got carbohydrates, the different categories of foods, cities, contain cocoa, energy, fat, fiber, images, the product name. There's a lot of good stuff in here. If we wanted to create a nutrition database that was that really focused on what was good to eat, how would you do that? Well, you'd have to decide which of all of these different components you liked, you cared about, and build essentially like an index, if you will. So let's start taking some of these. I see a lot of good vitamins in here. That's really cool, right? So let's see. We'll say vitamins are a good thing. So the more vitamins something has, the more we would want to score it. All right, so let's start by making we'll do something called vitamin score equals, and I want to take all those vitamins because they're all numbers. Add them up. All right, so there's our vitamin score. That's a pretty sensible formula. Let's go ahead and run that. And now if I look at this database, and let's arrange it by vitamin score. Which foods have the most vitamins? Per 100 grams of food. The ideal shake, vanilla superfood blend, applesauce, fettuccine, lots of vitamins, right? Lots of vitamins. But now, here's the thing. You're going to get, like fettuccine has like tons of B vitamins, right? Because it's a carbohydrate. Something that people care about a lot is a food like calorie dense, or how much fat does a food have. So we want to create something along those lines as well. But what we're going to run into is that vitamins occur in like very small trace amounts, right? Micrograms, milligrams. Things like fats and carbohydrates occurs at like the grams, even technically the kilograms, right? You eat a pile of bacon and eating like 70% of it's going to be fat. So we're going to want to do it's called scaling here. And scaling, it means taking that wide range of numbers and making them apples to apples so we can make that index together. So let's do this. Vitamin score. Yeah, let's do another mutate. And let's do scale. We're going to rescale. Scale the vitamin score equals rescale vitamin score. And we're going to do let's do a 1 to 100. So this is going to take that entire table And essentially, instead of having the individual amounts, it'd be just a 1 to 100 score. Now, let's do fat. Actually, let's do calories, right? Because calories, we're going to say that calories, maybe calories, calories from fat, calories from, what do we want to think about here? We've got salt, saturated fats. What are the things we know are bad for you? What other things we know are good for you? So fat's not great for you. It's not good for your health. Too much of it, I should say. So it's energy in kilocalories per 100 grams, energy from fat. So let's do that one. Because fats are, let's do energy from kilograms. So add and mutate. Scaled calories. Rescale. So again, this is going to create another 0 to 100, or 1 to 100, let's say. But what we might want to do is, if we think vitamins are good, that's a 1 to 100 positive, right? If we think fat is bad, then we should take this and make it negative. So if a food has a vitamin score of 70, but it has a calorie score of 80, and we make that 80 negative, then it's 70 plus minus 80, so it's a minus 10 food, right? So you can see how we're going to start manipulating this data. So let's do that. Take that rescale times minus 1. Did I do that right? I think I'm missing a parentheses. 1, 2, there's my rescale. That one there. Okay, the end of the mutate. Good. Let's clean that up a little bit, make it easier to see. And now let's add our call it healthy score. Equals scaled vitamin score plus scaled calories. Right, so we've got our negative thing there. And now instead of vitamin score, we're going to do healthy score. Let's go back into our table. So we've still got lots of, let's take a look, actually let's go to the end of the table here. So there's a scaled vitamin score, a scaled calorie score, our healthy score, in descending order. Something does not look right about the calories, though. Let's look at the actual database itself. Serving size, additives, ingredients from palm oil. Yeah, see if you want to do like a socially responsible database, you could. Let's see, food groups, composites, energy, kcal 100 grams. Let's do energy 100 grams instead. See if that comes up any better. Note also, for sanity's sake, let's knock this down to just the fields that we're working on so we can see what it is we're doing, because scoring through 182 fields every time is not productive. So we want product name. Actually, let's separate our processing from our presentation. What was the best practice? Product name. I want our scaled item score, scaled calories, healthy score, and wouldn't hurt to have raw data in there. So we got scaled vitamin score. Scaled calories still does not look right. Let's take out the -1. And just see what that looks like. Energy per one. What the heck? 100 grams of potato chips contains 92 fat. That's interesting. I wonder why some of these foods are coming up. Sorry. Strawberry layer cake. 100 grams of sirloin baker pillipit is 8,700. Let me go out on a limb and saying some of these are spurious values. Let's trim out everything that's over 5,000 calories because, frankly, I think that's a perfectly fine judgment to make. Right. Filter. Energy 100G, less than 5,000. Dying this morning. All right. So that makes sense. Those are fairly. Let's sort peach, mango, a grape. Hardwood smoked bacon. Why does ketchup? Ketchup does not seem right, but all these other things, oils, yeah, oil, any oil. Okay, I feel like we've gotten rid of some of the spurious data in that database. Okay, so with that in mind, now I feel like comfortable putting in our multiplier. So let's times -1. Okay, so we should have a small database here. And our healthy score instant oatmeal. So lots of vitamins, super on the vitamin side, still pretty hefty. So now the question is that good enough? Well, there are plenty of other things that we might want to add in here, right? So let's go back to our list. Fiber per 100 grams. If you like fiber, fiber is good for you. Fiber is also one of those things that nutritionally is filling, right? Which is a good thing to have. So let's add in scale fiber. Just going to copy this whole line here for sanity's sake. fiber 100 grams. That's fiber score. Now, what's you're going to notice is that we're going to start tilting the scales around. So now you have to start getting to more complicated math. Do you want to do an average of the positive attributes and an average of the negative attributes? It's a valid question. Scale fiber 100 grams. Let's see what happens. So now we have some sandwiches and soft breads in there, organic 0-calorie sweetener blend, yep. Prebiotics, xanthan gum, ginger, organic moringa superfood tea bags. That sounds tasty. Sugar and spice cinnamon sticks. And one of the things that's interesting here is that a lot of these things are like seasonings and stuff, so if we go back to our original database, there's some categories in here. So you have the product name, brands, categories, meal replacements, cooking helpers, snacks, plant-based food and beverages. So if there was a specific thing you wanted to go after, like a category, you could use the categories to buy things and specify whether something's organic or not. Let's see, ingredients would be important if you had a gluten sensitivity. What traces of items, serving sizes, additives. Let's see what's in some of these English categories here. Fat-free milk, meat, breakfasts, meals, packaging. Okay. Let's do this next. What if we want to, let's go back to our field list. What are some other things that we might want to do with this? What are some other facts or things? Main categories. Let's put it in. There you are. Meal replacements, sugars. So, I like that. I like the fact that you have these main categories. Let's do this. Let's do a group by main category. And in each category, what would be the top foods? So top N. Let's do a top 10 and weight it by our healthy score. Let's see what this looks like. Very good. Range by category. Advent calendars, alcoholic beverages, Alfredo sauces, almond butters, olive oil. There's a lot of categories. Appetizers, popcorn cheddar, apple pies. So what we've got is these huge main categories, but you could start to put together like menus of food. So you get the idea of what we're doing here. We're building a database that's a subset of another database, adding our own special sauce of data and our choices that we're going to make for these algorithms to say, like, yeah, I care a lot about fiber. I want filling foods, or I want high fiber foods. You could say, I want lower calorie foods, and deduct calories for it. You could actually, if you really don't like high calorie foods, you could take that multiplier and put your thumb on the scale pretty heavily, make that a multiply times a -10, right? You're going to clobber a lot of the food in here. So let's take a look at that small data table now. Right, so you've got your healthy score. Everything's going to be condiments. Like there's many things, tea bags, etc. Because you've said, I want no calories at all in anything that I do. So you've got fiber, which is positive, but you've got almost no energy. This is how you make content, right? Because now you take these outputs, you turn them into infographics, you turn them into meal plans, you turn them into whatever you want. You build your own algorithm. If you have a point of view that you want to espouse, like paleo or keto or whatever, you can do that. You can say, if you have like carbohydrates is a bad thing, you can say, I want -5 on carbohydrates, and all that goes into the score. And then you have the ability to turn that into any form of content. Top 20 foods. Start making a list of those. Top 20 foods that are high fiber and low glycemic index for diabetics. There are scores in here for processing. So there's what's called a NOVA score. Is it a processed food? Top low processed or non-processed foods. If you want to eat, was it farm to fork, farm to table? So it's up to you. But this is what you would do to build custom content that nobody else has. We all start with the same data source, right? We all start with the Open Food Facts database. But it's everything that you engineer on top of that that makes it special and makes your point of view what it is. And you're manipulating these fields in a good way, not in like an evil way. Well, I guess you could be evil about it. But you're deciding what does and doesn't go into the database. Now, I will be the first to say I am in no way qualified to be a nutritionist or anything medical related. So please do not take any of this as medical advice or health advice. Before you do anything, contact a qualified healthcare practitioner, not some guy on the internet, and figure out how to use this information in a positive way. But from a marketing perspective, take a data set and transform it into advanced content that nobody else could have, that nobody else would have your point of view on it. So thanks for watching and following along. Hope that things are going well for you. If you have follow-up questions, join our Analytics for Marketers Slack group. Go to trustinsights.ai/analytics for marketers and enjoy spending time there asking fun questions about analytics. I'll talk to you all soon. Take care.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.